The goblin shark looks like a shark. That's what your brain tells you the moment you see one. It's got fins, gills, cartilage, teeth. It swims through salt water, it hunts, everything checks out. But it's not a normal shark. It's not even close to a normal shark. It's something that evolution built in the dark, literally, and then apparently forgot about for 125 million years. This thing has a jaw that launches out of its skull like a spring-loaded weapon. Its skin is translucent. Its snout is shaped like a blade. It hunts completely blind in water so dark that light doesn't reach it. And we've never, not once, observed one giving birth. So, how does it find food with no eyes? Why does its face look like a construction accident? What is that jaw actually doing? And why, after millions of years, haven't we managed to answer any of these questions? Let's break down exactly why nothing about the goblin shark is normal. Every predatory shark on Earth uses the same basic attack strategy. It swims toward prey, opens its mouth and bites. Simple, brutal, effective. The jaw is anchored to the skull, and the skull moves toward the target. That's how it's worked for 450 million years of shark evolution. The goblin shark doesn't do that. Instead, it fires its jaw out of its face toward the prey, independently of its skull. In a process called slingshot feeding, the jaw isn't anchored like other sharks. It's suspended on connective tissue that works like a rubber band, loaded and released in a fraction of a second. When a goblin shark detects prey, elastic ligaments in its jaw structure, called the labial cartilages, compress and store energy like a coiled spring. When it strikes, those ligaments release, and the jaw propels forward out of the rostrum, that flat paddle-like snout, at a speed scientists have measured at up to 3.1 meters per second. That's faster than you can blink. The jaw extends forward by about 8.6% of the shark's total body length. On a 12-foot shark, that's over a foot of jaw extension, completely outside the skull. It snatches the prey and snaps back in milliseconds. Think of it like this. Imagine if you could detach your lower face, launch it 6 inches forward, grab a burger, and retract it before anyone noticed. That's approximately what's happening. High-speed video captured in a 2008 study by Commuter et al., published in the journal Ichthyological Research, is the clearest evidence we have of this mechanism in action. The footage shows the jaw extending and retracting in 0.31 seconds. The entire strike, detection, launch, capture, retraction, happens in under a third of a second. Prey doesn't have time to escape because the attack begins before it even registers movement from the shark. But here's where it gets weird. That's not even the strangest feature of its face. Shark snouts are streamlined. Every performance-optimized predator in the ocean has evolved a rostrum, the technical name for the snout, that minimizes drag. You've seen it on great whites, on makos, on hammerheads. Even the strange flat heads of hammerheads improve hydrodynamics. Form follows function in shark anatomy, always. The goblin shark has a flat, elongated, blade-like snout that extends far out in front of its face, sometimes making up nearly 40% of its head length. It looks like someone welded a surfboard to a shark's forehead. From an aerodynamic standpoint, it makes no sense. It increases drag, it's fragile, it creates more resistance. By every rule of shark design, it shouldn't be there. Except it's not decorative, and it's not for sensing vibrations, which is what most people assume. That rostrum is packed with ampullae of Lorenzini, specialized electroreceptor organs that detect the faint electrical fields generated by the muscle activity of other animals. In the absolute darkness of the deep ocean, where vision is useless, where echolocation doesn't work, the goblin shark uses its rostrum as an electromagnetic antenna. When any living creature moves a muscle, any muscle, it generates a tiny electrical field. The goblin shark's elongated snout detects those fields across short distances. It doesn't see its prey. It doesn't hear its prey. It feels the electricity coming off its prey's heartbeat. The density of electroreceptor pores on a goblin shark's rostrum is among the highest of any shark species studied. A 2016 study examining specimens collected from Japanese trawl surveys found that juvenile goblin sharks have proportionally longer rostrums than adults, suggesting the snout may be more critical in early life when the shark is hunting at its most vulnerable and most dependent on non-visual cues. This next part broke every rule we thought we knew about deep-sea metabolisms. Active hunters, Sharks, especially, are muscle. They need lean, powerful bodies to pursue prey. Deep-sea animals that don't move much tend to be flabby and slow, but they pay for it by having limited range and poor maneuverability. You can't be both slow and squishy and also an apex predator. Nature doesn't usually allow that. Goblin sharks are soft, flabby, and have almost no calcified cartilage compared to other sharks. Their bodies are so waterlogged and low density that they're essentially neutrally buoyant, meaning they can hover in the water column without effort, like a submarine at trim depth. Their muscles are extremely weak relative to body size. They're terrible swimmers. They have an enormous oily liver, potentially up to 25% of their total body weight, which acts as a buoyancy organ. This makes sense only when you understand their strategy. The goblin shark isn't a pursuit predator, it's an ambush predator. It doesn't chase, it waits. That floppy, waterlogged body allows it to hover silently in pitch-black water, expending almost no energy for long periods. When prey drifts close enough to trigger its electroreceptors, the jaw fires. The shark barely moves. The jaw does the work. It's essentially a giant, slow-moving trap with a spring-loaded face. The goblin shark's liver oil, mostly squalene, is so abundant that it's been studied as a potential industrial compound. Specimens collected from deep-sea surveys off Japan and Portugal have had livers so large they deformed the body cavity. One adult specimen examined in a 2004 study had a liver mass of approximately 18 kilograms on a total body weight of 74 kilograms. Nearly a quarter of the animal was liver. That's not anatomy, that's engineering. This is where it stops making sense as a modern animal. Sharks are grey, maybe blue-grey, maybe darker underneath, lighter on top. Counter shading, the classic oceanic camouflage. It's the default color scheme for a marine predator. Thousands of shark species across hundreds of millions of years of evolution have converged on the same basic palette. It works. You don't change what works. Live goblin sharks are pink, not the faint blush of a wound, not a subtle tint. They're vivid, fleshy pink, sometimes described as almost translucent, because their skin is so thin that the blood vessels underneath show through. They look like something that was never supposed to be seen by daylight, which technically is correct. In the deep ocean, where goblin sharks live, between 890 and 4,300 feet, there is no light. Zero. The color of your skin becomes irrelevant because no one is seeing it. Camouflage as a selection pressure essentially disappears. So over millions of years, the goblin shark's skin thinned. It stopped investing energy in pigmentation. The result is this eerily transparent pinkness. The pink coloration you see in photographs and videos is the circulatory system, the dense network of blood vessels running through the skin, literally glowing through the surface. It's like seeing the blood vessels in your hand when you hold a flashlight against it, except the whole body. Most photos you've seen of goblin sharks were taken of dead or recently captured specimens, and they show a greyish-pink colour because the blood has already begun to settle and the capillaries are no longer perfused. Live video of goblin sharks taken by deep-sea ROVs, including footage captured by the Schmidt Ocean Institute in 2018 off the coast of Monterey, shows the full, vivid pink coloration that earned them comparisons to raw meat. Wait until you hear what scientists found about what it actually eats down there. Deep-sea animals tend to stay deep. The pressure differential between the deep ocean and shallower water is so dramatic that animals adapted to one zone typically can't survive in the other. A creature living at 4,000 feet lives in a world of crushing pressure, roughly 120 atmospheres. Moving to 500 feet is physiologically catastrophic. Deep-sea species tend to be locked in their pressure zone. Goblin sharks perform what scientists call deal vertical migration. They follow their prey upward towards shallower water at night and descend again during the day. Specimens have been found at depths as shallow as 130 feet on certain submarine canyon walls and as deep as 4,300 feet. That's a pressure range that should be physiologically impossible for most species. The goblin shark crosses it regularly. Their uncalcified soft cartilage and gelatinous body tissues may actually help here. Rigid skeletal structures under extreme pressure changes can crack or deform. The goblin shark's soft, compliant body compresses and decompresses more flexibly than a shark with a highly calcified skeleton. It's built like a submarine with flexible walls instead of a rigid hull. Combined with that enormous squalene-rich liver, squalene has a very low compressibility. The goblin shark can manage buoyancy across an enormous depth range. It's not just tolerating the pressure change, it's using its weird anatomy to exploit it. In April 2004, a goblin shark was accidentally caught by shrimp trawlers operating off the coast of Taiwan at approximately 890 feet. It was alive and healthy when brought to the surface, an unusual outcome for a deep-sea animal brought up that fast. It survived for a week in captivity at the Tokyo Sea Life Park before dying. That brief captivity provided more data on goblin shark behavior than any controlled study before or since. You won't believe what the goblin shark does next, specifically in terms of just how long it's been doing all of this. We've covered the jaw that fires out of its face, the electromagnetic snout, the body built like a waterlogged bag, the translucent pink skin, the depth-crossing commute, the 125 million year freeze on evolution. But there's one fact about the goblin shark that makes all of that seem almost reasonable. We have never once seen a goblin shark reproduce. Let me repeat that. Not a single documented case, not one observed birth, not a single pregnant female examined in a lab, not a pup attributed to a known mother with certainty. Nothing. We know it reproduces, it exists, so logically it must. But how, where, when? Completely unknown. For a species that has survived for 125 million years, across 5 mass extinction events, this is a species that has successfully reproduced enough to outlast nearly everything that has ever lived on Earth, and we have zero data on how. Based on its shark biology, scientists assume it likely gives birth to live young, like most sharks. Based on body cavity dissections, females appear to have a 2-lobed uterus. One partially developed embryo was reportedly found inside a female specimen, but the documentation was incomplete. That's it. That's the entire reproductive record for a species that's been alive since the Cretaceous. While the dinosaurs were going extinct 66 million years ago, this species was already middle-aged. While the Roman Empire rose and fell, while every human civilization ever recorded played out its entire history, the goblin shark was doing something to keep its lineage alive in the deep ocean. And we have absolutely no idea what that something looks like. Scientists at the Japan Agency for Marine Earth Science and Technology, studying specimens collected from Pacific trawl surveys, have estimated based on analogy with related species that litter sizes might be between 2 and 10 pups per birth. But that's extrapolation, not observation. The honest scientific answer to how does the goblin shark reproduce is we don't know. Reproduction isn't the only mystery. It's not even the biggest one. Despite the goblin shark being described by science in 1898, over 125 years ago, fewer than 50 specimens have ever been properly examined and documented. The vast majority of those were accidental trawl captures. We've never deliberately found one in the wild. We've never tracked a living specimen for more than a few days. We've never observed courtship, territorial behavior, schooling, or any form of social interaction. If such things even exist for this species. We don't know its population size, we don't know if it's endangered, we don't know its maximum lifespan, though based on growth rates extrapolated from similar sharks, it could live for several decades. We don't know its range with precision. Specimens have been found off Japan, Portugal, South Africa, Taiwan, Australia, the Gulf of Mexico, and the Maldives, meaning it's potentially globally distributed, one of the widest ranges of any deep-sea shark. But we've never systematically surveyed for it. In 2004, following the Taiwan earthquake and subsequent trawling activity stirred up by shifting seafloor sediment, over 100 goblin sharks were accidentally caught in a matter of weeks. That's more specimens than had been documented in the previous century. They appeared briefly, in abundance, and then disappeared again. Where did they go? Why were they there? No one knows. If the goblin shark, a species that's existed since the Cretaceous, that appears globally distributed, that apparently survives pressure ranges that should be physiologically catastrophic, is still this mysterious to us, what else is down there that we haven't even found yet? We've mapped less than 25% of the ocean floor with high resolution. The deep ocean covers more area than all of Earth's land combined. The Goblin shark has been hiding in that space for 125 million years. It's not alone. The Goblin shark fires its jaw out of its own skull. It hunts by sensing electricity in total darkness using a paddle-shaped face that looks like an engineering error. It's built like something between a shark and a wet paper bag. Its skin is so thin you can see the blood underneath. It crosses pressure ranges that should kill it. Its family line is 125 million years old and has barely changed since the Cretaceous, and we have never once seen it reproduce. It's a spring-loaded trap with a face. It's a 125 million year old evolutionary holdout. It's proof that the deep ocean has been running its own experiment in parallel to everything we think we know about life on Earth. The Goblin shark isn't just unusual. It's proof that evolution creates things that shouldn't exist. Things that survived 5 mass extinctions not by being the biggest, the fastest, or the most aggressive, but by being perfectly, eerily, incomprehensibly adapted to a world we can barely access. Right now, somewhere in the deep Pacific, at 2,000 feet in water at 4 degrees Celsius, in total and permanent darkness, a Goblin shark is hovering motionless. Its jaw is loaded. Its rostrum is scanning for electrical fields. Its pink body glows faintly in absolute black. It has been doing this exact thing, in this exact way, since before the Atlantic Ocean existed. And it's not even the strangest thing we found down there.